Hello, this is Susan Poss. I'm a math instructor at Spartanburg Community College, and today I wanted to talk with you a little bit about adding rational expressions. Again, ratio means working with fraction form. And you can see an example here of two fractions. The first fraction is p over q, and then we're adding. Second fraction is r over q, and the main thing I wanted you to take note of is that these denominators are the same denominator. So we're going to keep that, what's called the common denominator, over here in our answer. And the part that's going to add up or combine are these pieces up here in the numerator. So when we add rational expressions, we're going to be looking to have a common, same, matching denominator, which we're going to hold on to, and then we're going to be adding just across the numerator. So there, here's our first example, and you can see as you look at this, the first thing I want you to notice is that it is addition, and the second thing I want you to notice is that the denominators do match. So as long as they are already matching denominators, what we're going to do is put down that single common denominator. So there's the matching common denominator, x squared minus 1. And then we're going to pick up these pieces across the top, the numerator x added to the numerator 1. So at that stage, we've combined the p and the r, and we've kept the common q in the denominator. Now remember, we talked about simplifying or reducing if possible, and this particular one will reduce. The way you reduce is you factor anything in a numerator or denominator that will factor, and of course the numerator is prime. But the denominator is factorable. So this is the difference of two squares. You can see I factored it into x plus 1 and x minus 1. Here I see a cancellation process. So I'm simplifying. And so my final reduced answer is 1 over the denominator x minus 1. All right, so let's try one more example where the denominators are already matching. So that's the first thing you need to check when you see that it's an addition problem. X squared plus 7x plus 10 matches there. So we're just going to write that common denominator down in our answer form out here. And then I'm going to pick up the pieces in the numerator, so I'm doing a 1 plus 2x plus 3. Now I need to do a little simplifying up here, so I'm noticing that I have like terms, positive 3 and positive 1, so let me go ahead and combine those to get 4. I don't like the way that looks. Let me straighten that up a little bit there. There we go. So we're done with the addition process, but remember, we're always supposed to, whenever possible, reduce the fraction, and that means we have to do some factoring. So I'm going to come down here and do a little bit of factoring. I see a common 2 in that numerator, which I'm going to take out. And remember, the reason I'm factoring is that before I can simplify or cancel out, these have to be in factored form. They have to be things that are multiplied together. All right, so I'm looking for two numbers that multiply to give me positive 10 and add to give me positive 7. Whoops, I see a mistake I made back up here, so let me go fix that. There we go. So let me repeat that. When I pull out the common 2 here, I have an x left and then dividing that 4 by 2. So let me do, again, notice that these connecting operations in here are times operations, which make this cancellation a legitimate operation. And it looks like my final result has a single 2 in the numerator and an x plus 5 in the denominator. So those are the easier beginning ones where the denominators are already in matching form. Let me talk to you about what we do when the denominators do not match. And we will need an LCM, or you may know that as an LCD, a lowest common denominator or a least common multiple. So to get that, we're going to completely factor each polynomial, including prime factors for numerical factors. And this is going to be in the denominator. Let me make a note there. We don't need to worry about factoring the numerator here in order to find the lowest common denominator. And then this is going to be an important sentence. You're going to hear me saying this. Form the product, of course that means multiplication, of all factors that appear, So even if it only appears once, we're going to put it into our product, using each factor the most number of times it appears in any one polynomial, and I'm going to put slash denominator because I'm going to be working here with denominators. All right, so let's see if we can get our steps together and try one. So the first thing I'm going to be doing is finding the LCD. That's kind of the tricky part. Then we're going to rewrite each fraction in an equivalent form with this new denominator. We're going to add the numerators and keep the common denominator. That's what we were doing earlier, and then we're going to see if we can reduce. So 4 important steps there. All right, so let's see if we can implement those steps now. So you'll notice this is an addition problem, and I hope you also see that these denominators do not match. So we've got a problem. How do we find the LCD? Well, we said we were going to try and factor, but that first denominator is prime, so I cannot factor that one. And the second denominator is also prime, so I cannot factor that one either. When that happens, when neither denominator can be factored, remember we're going to form that product of the factors. So I've got a y minus 3 factor and I've got a y plus 4 factor, and they both have to be included in my LCD. So that's going to be my LCD. That's sort of like if you had a simple fraction, 1 over 3, and you were trying to add that to I don't know, 5 over 2, you can see that the LCD would have to be a 6 because you would form the product here of the prime 3 and the prime 2 to get the LCD. So numerically, that's how that would look. Algebraically, it's going to be the product of y minus 3 times y plus 4. So let's go down here and see what happens next. So after you determine what the LCD is, the lowest common denominator. Let me write it out here. I like to think of this as doing a comparison. So we're going to compare the existing denominator y minus 3 to what we want in the LCD, and you can see that the y plus 4 factor is missing. So you're going to fill that in, both numerator and denominator. Now you have a denominator that looks like the LCD. But you've got this extra multiplier that you have to include in the numerator. So then moving past the addition sign, we're looking at the second fraction now and doing a comparison to the LCD that we want. You can see we already have the y plus 4, so we now have to insert this factor multiplier of y minus 3 and both the numerator and the denominator. So that's the process of getting these denominators so that they now match. I see they're in a different order, but they have the same factors. So these are now my matching denominators. Let me work it out for you. So we're going to combine both of these fractions into one fraction bar with one common denominator. And we're going to pick up, and I'm going to put in an extra step here so we don't lose track of where things are coming from. We're going to pick up this numerator, add it to the other numerator. So I'm going to distribute this y. And I'm going to distribute this 6. And then it becomes just kind of a copying process where you have to tag along and bring this common denominator as you sort of work out the numerator. Clean that up a little bit. Okay. So now in the numerator, I see a couple of things here that are common. I see a 4y and a 6y that are like terms. So I'm going to combine those. Again, just keep copying down that denominator. And I'm doing one last thing. I'm trying to think if this will factor and match up with something down here where I can do a cancellation. So I may erase this. Let me just try and think about whether or not I can factor that numerator. And secondly, will one of those factors match what I have down here in the denominator? So I'm looking for two numbers that multiply to give me a negative 18. And I'm thinking through a series of 1 and 18, 2 and 9, 3 and 6. And I think that's it. And I don't see any combination there that's going to give me a value of 10. So even though I tried to reduce, this one is not going to reduce. So I'll stop at that spot right there. And again, leave the denominator in its factored form. That's usually the best strategy. All right, I have one more for you. This one's a pretty involved one, but I wanted to show you all the steps. So the first step is, notice what the operation is. We're adding. So you've got to have matching denominators, which we do not have. So we have to first find an LCD. How do you do that? You factor each denominator completely. So here's the first denominator factored. You can write that x plus 3 squared, or you can write it x plus 3 expanded out. And then here's the second denominator, x squared minus 9. That's the difference of two squares. So here it is in factored form. Third denominator has a common 2. So we're going to pull out that common 2, and you see the factored forms. So how do you find the LCD? I've got this beneath, but I want to talk through this. For the LCD, remember, you're going to list each factor that occurs, and you're going to list it the greatest number of times in any one denominator. So I need an x plus 3. I can see that. It occurs twice here and once here. So you're going to list it the greatest number of times it occurs. So that's twice. So that takes care of the x plus 3. I also see an x minus 3 that I need to take care of. I've already taken care of this x plus 3 here because it occurs twice, once. I listed twice. I need that one once. And the other missing piece is the 2. So this LCD is going to have the 2. It's going to have two factors of x plus 3. It's going to have one factor of x minus 3. So let me scroll and show you how this all works out down here. There's your LCD. There are your denominators in factored form, and this is where we start to do our comparison. So let me talk through here, and then I'll show you what it looks like. So as I do the comparison, the first denominator has two factors of x plus 3, but you can see it's missing the 2, and it's missing the x minus 3. So in a minute I'll scroll down and you can see how we fill all that in. I look at the second denominator, it's got an x plus 3 and an x minus 3, but I'm missing another factor of x plus 3, so we're going to fill that in. And we're also going to fill in the 2. And I'm about to forget to fill this in up here. Sorry. And then here we've got the 2. And we've got a single x plus 3, so we are missing another x plus 3. And we are missing an x minus 3. So I'm writing kind of sloppily here because I know I'm going to show it to you in a second. But I just wanted to see how it's a comparison of what you've got to what you want and then fill in the missing pieces. So here you can see it a little bit better. So we filled in all the missing pieces there. And let's see if I can finish it up for you. Hope you don't get any like this on a test. This is pretty terrible. There's the 2, there's the x minus 3, and here's the x plus 3 quantity squared. And so where am I getting that? I'm getting that from all of these denominators that now match. So I'm writing it down one time. Now I'm going to pick up this, and I'm going to pick up this, and notice that I've got an addition going on in there. And here's my addition, and I'm going to pick up all of this. Okay, so let's take it one piece at a time. Let's distribute the 2. And let's come back here and distribute the 2. And then we're going to need here our first outer inner last FOIL operation. The middle term is going to drop out. I hope you see that. There's the plus 3x and the minus 3x adding up to 0, and then there's the minus 9 on the end. So here we go copying. Remember, you just kind of have to keep copying down the common denominator. All right, so let's do some combining. I'm going to lead off with the x squared. So I'll check that one off. And then I see a plus 2x and a plus 2x, so I'm going to combine those. So I'll check those off. I see a plus 6 and a minus 6, so those are adding to 0. And then I see a minus 9. And I'm almost finished, because I'm trying to think if there's any way to factor this using numbers that will multiply to give me -9 and add to give me a positive 4. I can't think of any numbers that would do that. 9 and 1 and 3 and 3. There's no way I'm going to get a 4 out of that. So I'm going to stop right there. And again, we agreed that you can leave this denominator in factor form.